Okay, substitution rule for definite integrals. Here we go. Okay, so here's what happens. If we take an integral that you need to evaluate, a definite integral, so you have bounds, you have a and b, you know, what we do is we find the antiderivative and when we plug in a and b. But if you're using substitution, what you can do is instead of substituting that u back in at the end, like let's say u is x minus 3. Instead of substituting that x minus 3 back in, you don't have to do that. You can just work with u. If you find out what u of a is and what u of b is. So if we simply change the bounds, we can work with u as opposed to x. And it actually provides a little bit of a shortcut. So evaluate the following definite integrals using the substitution rule. Now, you can do it the long way, but I will not give you credit for it on the test. When I tell you use the substitution rule, I want you to use that. So we need to find this antiderivative. So let's review. Before we do it the 2 and the 0, let's start with this. What is u going to be in this situation? X squared plus 3. So du is equal to 2x dx. Divide by 2, you get 1/2 of du is equal to x dx. Am I now ready to substitute? Yes. I'll show you. We replace x squared plus 3 with u to the 4th power. We replace x dx with 1/2 du. I put the 1/2 out front. Got the du. And now you change your bounds. So I can't just leave the 0 and the 2. I'm going to change it. Anybody know what I changed the lower one to? I changed the bottom one to 3 because you plug in 0, you get 0 squared plus 3 is 3. And then the top one's going to be 7. Okay. So now we don't have to deal with the x squared plus 3 anymore when we substitute. We can just work with this now. No substituting back in. What's the antiderivative of u to the 4th? U to the 5th over 5 times 1/2 is over 10, correct? And now we're going to evaluate that at 7 and 3. Don't need it because it's a definite integral, not an indefinite integral. Question? Yeah, I won't even look at the rest of your test. I'll just throw it away. What a naughty teacher he is. All right. So, we evaluate it. Uh, 1656.4. Now, I want to be clear. That would be the same as x squared plus 3 to the 5th power over 10 evaluated at 2 and 0. So if you would have plugged u back, or x squared plus 3 back in, then you would do the bounds from 2 to 0. Is it plain for you to see now that these are the same? If you plug in 2, you get 7. If you plug in 0, you get 3. So And you may even prefer that because you have a 0 there. You might like that better, yes. No bad questions. Yes, yep. Anytime you evaluate the definite integral, you're still, yep, that's still the area. And, yeah, cool. All right, we just got one more, then you got your assignment. Whoa, savvy! Okay, let's give it a shot. What do you think? You've got it, Billy Barber. She says that u is equal to sine of x. So du is equal to cosine of x dx. Do we have it cosine of x dx? We sure do. So I have my new integral of u to the third du. And what will my bounds be? Sine of 0 is, my goodness. All right. Sine of 0 is 0. Sine of pi over 2 is 1. So, we know you have it. So, yeah. So, exactly. So, this is what a lot of people make mistakes on, actually. We haven't taken the antiderivative yet, have we? But some people are like, okay, yeah, now we can just plug stuff in. They figure, well, we've done a step, so now we can just plug stuff in. No, you've done your substitution step. Now, what's the antiderivative of u to the third? Sure. Yep. Depends. Are you using this or are you using that? It depends on what you want to do. If you want to check it, you could plug in this at the very beginning. But then you got to do 0 pi over 2. Everybody got that? Okay. That's all I got. I'll give you your assignment. There you go. Good luck.